Hi and welcome to this video. In this video, I would like to teach you about arithmetic operators available in C language, arithmetic expression and typecasting. Let's begin. C language supports arithmetic operators to perform all the arithmetic operations. Let's see the list of arithmetic operators available in C. This is the list. Plus for addition, minus, subtraction, star for multiplication, slash for division and percentage symbol is for modulus operation. Now we will write a C program to perform all these arithmetic operations and then we will see what is arithmetic expression and what is typecasting. Now let's write a program to perform all the arithmetic operations. This is the basic structure of our C program. Now let's take two numbers. First we need to write data type integer. Let's take a comma b. Instead of giving the names a comma b, we already learned in the naming conventions for the identifiers better to give meaningful names. So I am naming it as first number comma second number. These two variables are for taking input. Then we need to declare 5 more variables. One for addition, let's declare the name of the variable as add. One for subtraction, sub. Mult for multiplication. Division. Division we may get number with decimal. So we need to declare float variable for division, float div. And modulus. Modulus means remainder of the division. That one is also integer. So we need to declare as integer variable. At the end of the declaration we need to give semicolon. First we need to read first number and second number. Let's give information to the user to enter first number. For that use printf enter first number and let's say the user give the number as 100. We need to read that number. To read integer we should use scanf. Scanf. For integer we should use percentage d. D for digit, comma. We need to give the integer argument. The integer argument is first number. Now let's give information to the user to enter second number. Let's say the user given the number 25. We need to read this number, need to store onto the variable second number. Scanf percentage d and we should give the argument second number. Now we need to do addition, that is first number plus second number and need to store onto the variable add. Add we should give the assignment operator first number plus second number. Now let's do subtraction, let's do multiplication, let's do division, let's do modulus. Okay, we performed all the arithmetic operations. Now we need to display the values of these variables onto the monitor. For that we should use printf. Let's display the result of all these variables with headings. Addition equal to, the result of addition is integer, that is percentage d, comma. We stored the result of addition in the variable add. So we should give the variable name add here. And to display the results in the separate line, we should give slash n here. Similarly, we need to display the result of these variables. The result of the division is a float value. So we need to use the format specifier percentage f. We know that this is the declaration part. In the declaration part, the memory will be allocated for these variables and its initial value is not given. So its initial value will be garbage value. Let's see the memory representation for these variables. This is the memory representation. For first number, second number, add, sub, mult and mod variables, 2 bytes of memory will be allocated because these are integer variables. But for division, 4 bytes will be allocated because this is the float variable. And let's assume these are the garbage values, and let's assume these are the memory addresses for these variables. Now, this statement will ask for the user enter first number. Let's assume we given the number 100. Then scanf will read this as an integer and it will store at the memory address allocated for the first number. What is the memory address we assumed for the first number? 2001. So, the value 100 will be stored at the memory address 2001. This statement will ask for us to enter second number. Let's assume we given the number 25. Now scanf will read this as an integer and it will store at the memory address allocated for the second number, that is 2003 memory address location. After that, this statement will perform addition. Then coming to this statement, first number minus second number will be evaluated and it will be stored onto the variable sub. Similarly, multiplication, division and modulus will be evaluated and will be stored onto their respective variables. After that, we are displaying the result of addition. Addition equal to, in place of %d, the value of add will be displayed. After that, /n will move the cursor to the next line. Then this statement will display subtraction equal to, in place of %d, the value of the variable sub will be displayed and /n will move to the next line. Similarly, multiplication, the value of the variable mult will be displayed, moves to the next line. And coming to the division, the value of division will be displayed as a float variable. We already learned that the float will give maximum of 6 decimals. If you want only 2 decimals, we need to give .2f. And coming to this modulus, in place of %d, the value of the variable mod will be displayed. So, after execution of these statements, the result of the variables on the memory will be like this: 125, addition 125, subtraction 75, multiplication is 2500 and 100 by 25, division is 4, 100 mod 25, the remainder is 0. When we look at this statement, first number plus second number, this is called arithmetic expression. Then what is arithmetic expression? An arithmetic expression is a combination of operands and operators. Let's say in this arithmetic expression, first number and second number are operands and plus is the operator. By using operands and operator, we are performing an operation which is called arithmetic operation. So, what is the arithmetic operation we are doing in this statement? Addition. Here we are doing the arithmetic operation subtraction. Here multiplication, division and modulus. So, an arithmetic expression is a combination of operands and operators. And coming to this concept of typecasting, let's say for example, when we look at the division operation, first number by second number, let's consider 125. 100 by 25 equal to 4. It means integer by integer. Now, let's consider the first number as 10 and the second number as 3. But this is the expression which is of int by integer type. Int by int will take integer only. It means the result of 10 by 3, we will get only 3. We will lose this decimal part. If we observe here, we are storing the result of division onto the float variable. It means we are doing the operation here like this: float equal to int by int. Even though we are storing the result of division onto the float variable, still we will get only integer. we will not get this decimal part. This is because of the arithmetic expression int by int. We will take only integer. So, to get the decimal part also, we need to convert this one into float or this one into float. If we convert first number into float, then it will be like this: float by int. Float is 4 bytes, int is 2 bytes. Then the result will be converted into the higher type, which is 4 bytes. It means we will get the result in float value. Similarly, if we convert the second number into float, first number remains int only, the result also will be float. It means we need to convert either first number into float or second number into float. For that, we need to apply the concept of typecasting or type conversion. To do typecasting, we should use parenthesis and we should write to which type of data we are going to convert this variable. We want to convert this variable into the float data type, we should write float here. Or if we want to convert this one into float, then we need to write float here. And one more thing to note here, at the declaration, the second number will be integer only. At the time of performing division only, the second number will be converted into the float data type. It means if we take 10 and 3 as examples for the first number and second number, it will be done like this: 10 by 3.0, that is integer by float, will get float, so that we will get 3.333, which is of 6 decimals. If we convert first number into float, then at the time of performing division, it will be like this: 10.0 by 3, that is float by integer, float. And one more thing I would like to say here, when we want only 2 decimals, it will check the third decimal. If it is 5 or above 5, this number will be rounded to the next number. It means here when we write dot to f, the result will be 3.33 only. This is because the third number is below 5, so it remains as 3 only. Let's take the numbers 3 by 4. The result of 3 by 4 is 0.75. The remaining 4 decimals will be zeros. Now, if we write dot to f, the result will be 0.75 only, because the third number is 0, it is below 5. Let's say for example, we want only 1 decimal. Then it will check the second number, it is 5 or above 5. Then we will get 0.8. It means this number will be rounded, which is 0.8. So, what is typecasting or what is type conversion? Changing from or converting from one type of data to another type of data. This is one of the very important question for the interviews. And there are 2 ways of doing typecasting: implicit typecasting and explicit typecasting. The typecasting what we did just now, this one is the example for explicit typecasting. And about implicit typecasting, I will teach you in a separate video. Now, let's execute this program in our code blocks IDE. Let's create a new file. This is the program we learned just now. Now, let's compile this program. Our program is compiled successfully. Let's run this. Okay, this is the result of addition, subtraction, multiplication, division and modulus. Let's exit this program. Now, let's run our program one more time. Let's give 10, 3. We can see here 3.333, 6 decimals. Now, let's make it only 1 decimal. Let's exit this command prompt. Dot 1f. We can see here only 1 decimal. Now, let's give the input 3, 4. Let's run the program. 3, 4. we can see here the result of 3 by 4 is 0.75. As we want only one decimal, so the result is 0.8. And the modulus of 3 by 4 is 3. We will stop here for now. Thank you very much for watching this video. See you next time.